Okay, can somebody remind me what it means for two polygons to be congruent? What was the first way that we proved that two polygons were congruent? Let's make it easy. What was the first way that we proved two triangles were congruent? What does the word congruent mean?
Same.
They're parallel. No.
Okay, so Harry says that they're the same size and the same shape. So how do I prove that they were the same size and same shape? What did I do to prove that, let's say, two triangles were the same shape?
The angles.
So the angles had to be what, Nikki?
They had to be congruent. So they had to be.
So for congruent, for two polygons to be congruent, all angles were congruent. And what about their sides?
Congruent.
All the sides had to be congruent. Okay, and what I'm talking about when I mean all angles and all sides, I mean the corresponding angles and the corresponding sides. Those are the ones that match up on the two figures. Okay, so to call something congruent, we had to show that all angles and all sides were congruent. Okay, we are done with congruency for a little while, and the next thing we're going to be talking about is similar polygons. The difference here is that similar means same shape. Same shape. In order to prove that figures are similar, the first thing we're going to do is all angles still have to be congruent. This is why I could not have an angle theorem for proving triangles were congruent. Remember when I drew the 30, 60, 90 that was small and the 30, 60, 90 that was big? They were same 30, 60, 90 triangles, but they were not congruent. Okay? And corresponding side lengths are proportional. So in order for two polygons to be similar, all of their angles must be congruent, and all of their corresponding side lengths must be proportional.
I think it's math. You could kind of have all of the some of the writing being in all caps.
Actually, it's a military thing.
Because one of my math teachers mostly only wrote in all caps.
Who's this video going to again? Your YouTube channel, or
It will be going to YouTube, and I'll be downloading it to Google Classroom.
does that mean that they're going to hear everything we say, or are you?
That's
gonna
correct.
take
They will hear
notes?
everything that you say because I have a little speaker thing that picks you up.
I apologize in advance.
Okay. So corresponding angles congruent. Corresponding side lengths are proportional. So I'm going to show you what I mean by that proportional side lengths thing. So bottom left angle is marked with bottom left angle. Top angle is marked with top. And bottom right angle is marked with bottom right. Does everybody see that? So I have the three angle pairs are congruent to each other. And notice here that if I go right, bottom, left. So let's go right, bottom, left, over, right, bottom, left, and I were to simplify all of those fractions, I would get the same number. That's what it means for the pieces to be proportional. That when you set up their relationship with the corresponding pieces, that you end up with the same fraction. Any questions on that? So I have now labeled the two triangles. Part of your work today is to write, list all pairs of congruent angles, and then write the ratios of the corresponding side lengths using a statement of proportionality. So here, angle A is congruent to which angle?
Angle B.
Yeah, it's supposed to be a D.
Oh.
Angle B is congruent to which angle? Okay. And angle C is congruent to which angle? Okay. So that's how you write your congruent statements for angles. Now what we're going to do is we are going to write our proportionality statement. Since I'm using a triangle, I have three sides, so we'll have three things separated by equal signs. Okay, and now what I want to do is I want to list the corresponding sides together. So what I'm going to do is I'm just going to go around my triangle. AB, BC, CA or AC. And now I need to list the corresponding sides that go with those. Okay, and they're the same pieces that match up with your triangles. So if you have a drawing that has one of them like right side up and the other one upside down, my recommendation is to turn both of them right side up, get the corresponding angles all in the same locations. That makes this really easier. So A goes with D, B goes with E, B goes with E, C goes with F, A goes with D, and C goes with F. Make sure this stuff matches. So this is saying segment AB. That's this upper left. What is the upper left segment here? It's DE. Then it says BC. That's the right-hand segment. BC, the right-hand segment here is EF. And the last one I have is AC, which is the bottom segment. And AC matches DF. Okay, remember if I put a segment without the segment bar on top of it, that means the length of the segment. Okay, just a quick reminder. I can write it like this, the length of AB, and that means the exact same thing as writing AB without the segment bar over the top. No, I don't. The other thing we need to talk about when it comes to regard to similar figures are its scale factor. The scale factor is what I need to multiply each side in the first one by to get to the second one. So, starting at triangle ABC, what do I have to multiply each side by to get to triangle DEF? I multiplied by 2. So, to get from triangle ABC to DEF, I had a scale factor of 2 to 1. This is our new one. This is our old one. Remember that this is one way for me to write a ratio. Another way to write a ratio is as a fraction. Okay? The new one, 6, over the old one, 3, equals 2. Well, 2 as a fraction is 2 over 1. So your scale factor is just the new one, the ratio of the new size to the old size. So first thing you're going to want to do is you're going to want to compare every set of sides to make sure you get the same fraction. And then you're going to use that fraction either right side up or upside down, depending upon which one you wrote on top and which one you wrote on the bottom. My recommendation is you write new on top for all of these and old on the bottom. That way you don't have to flip it over at the end. It's like this one, I have 1 over 2. My scale factor isn't 1/2. My scale factor is actually 2 if I use the second one as my thing. Any questions on that? What I'd like you guys to do is please turn your books to page 359. On the bottom of page 359, there's guided practices 2 and 3. I would like you to start working on those 2 guided practices while I clean up the board. And while you're working on it, I'm going to pause the video and erase the board and get the board set up. So to find the scale factor of QRST to ABCD, QRST is the right-hand polygon, ABCD is the left-hand polygon. All I have to do is find a set of matching sides. And here's the thing to be careful with. Make sure that they're drawn in the same orientation. Is Q in the same spot as A? Is B in the same spot as R? C and S? And T as D. That's the first thing you want to do, is make sure they're both facing the same directions. Okay? Now I want to do something that has numbers filled in both polygons. So I'm just going to use the tops. So I want to write the top polygon, that's this one, or the top side of this one over the top side of that one. So that would be 6 over 12, which is 1/2. So that's your scale factor. You multiply everything on the left-hand polygon by 1/2, and that's going to get you your right-hand polygon. Everything meaning the side lengths. This one is straightforward. You can probably look at it and figure out what the x is. Hopefully everybody got 8. Okay? But the way you would set this up with work is I'm going to go right over right, x over 4 is equal to top over top, 12 over 6. So that's the way you would set it up. We always simplify before we multiply. 12 divided by 6 is 2, so I have x over 4 is 2. I solve for x by multiplying both sides by 4, and I get x is equal to 8. Are there any questions on finding the scale factor and using ratios to find the corresponding side lengths? Yes?
I think the smaller one goes on the bottom.
On this one, this is the top number. Left-hand side is always the top number. This one's the thing. What's going to go on top here is the one that has the letter. Okay, so these two are just flipped over of each other. This one, it's always top, bottom, or numerator, denominator. That's the way we learned how to do ratios. This one, we just set up our ratio. Here's another way I could have set up my ratio. I could have done right over top equals right over top. But this one's not as intuitive as the other way I did it. And you will get the exact same answer if you solve that ratio as we did the first time. You just have to have corresponding part over corresponding part equals the same set of correspondence. Any questions on our first part? I'm just trying to see what your homework is so I can determine where I'm stopping today. Okay, that's where we're going to stop today. Tomorrow, for those of you that did not do the Theorem 6.1, you do need to do Theorem 6.1 because that will be the first thing that we cover tomorrow in class. It's Theorem 6.1. Please make sure you do the vocab that was written down for you to do on Friday. Make sure that's ready to go. Because scale factor you should have already had in there, in your vocab and stuff like that. Yes, Nikki?
You said do
the key concept, corresponding lengths of similar polygons. Okay? Any other questions on what I've covered today before I write down the homework assignment? Ready for homework assignment? Okay. Today, which is due tomorrow, this is 6.1a. Yes, Kylie.
Can I?
Can you what? Do your homework? Yes, please. 1, you do 10. 14 to 18. 14 to 18. I guess she got her spoon. 23 to 26. 29. 31 and 32.
Cool.
Oh no.
And Kylie will do 29 also. That is the challenge problem because Kylie's trying to be challenging today. And that is due tomorrow at the beginning of class. We will cover the rest of section 6.1 tomorrow and do the second homework assignment.
That's fun.